Hi there! In this video we will explore how we can join tables using DBIx relationships. First off, let's start by exploring relationship types you will be met in your result classes and what they mean. Starting off, you might notice that we have a new table which is called admin comment. I've created this table to show one of the relationships we're going to discuss. Now just to give a quick overview, this table is quite simple, so we have three columns, which is ID, note ID and comment. The ID is the primary key, which is auto-increment. The note ID is a unique column that references back to the note table and it holds a foreign key. And the comment is simple VARCHAR field. I will provide SQL to create this new table in the video description. Once you have run the SQL, do remember to regenerate schemas through the dump script as we have done before. Right, so off to relationship. Basically, there are four main relationships you should concern yourself with, and these are belongs to, has many, might have, or has one. Starting with belongs to. Belongs to creates a relationship where the calling class stores the foreign class primary key in one or more of the calling class columns. And just to put it in simple terms, if you think about it, the name's quite self-explanatory. In our example, if you look at the note table, we have this relationship on the notes which points back to user that says belongs to. So what it means is that if you look at these entries in a notes table, we're going to find a relative entry in user table, which is going to be a single record, right? So we can have many notes belonging to one user, but we don't have a table structure where there are many notes shared between the users. And when you have one-to-many relationship, where the many side of things, in our case would be the notes, you would use the belongs to. Because, as I said before, if we think about it, in our case, we have users, we have nodes, and nodes do belong to users. The next relationship is has many, and has many creates a one-to-many relationship where the foreign class refers to the class primary key. This relationship refers to 0 or more records in the foreign table. As you might guess, then in our case, this would be our user table, where if you look at the existing relationship, we have one that is called has many and it points to nodes. As the definition says, it creates one-to-many relationships. And we have one user entry that has one-to-many note items in a note table. So just to quickly rehash, so we have a notes table where we have a relationship called belongs to that points to a single user because many nodes, but they can belong to one user. And if you look at the user table, we can say that user can have one-to-many nodes. And we can also see that this is indicated in plural form. The next relationship is called might have. And the might have creates an optional one-to-one relationship with the class. And this is where our new table comes into play that is called admin comment. Now, admin comment has a column for the note ID, which is currently set to be unique. So meaning the admin comment can only have a reference to a single entry in notes. And this is just a random example for, let's say, if you're an admin of a platform that manages nodes and you want to add some internal comments, you can say that for all the comments you want to add to nodes, there can only be one entry. And you don't want to create multiple comments, but every single time an admin adds internal note for the note table, you should edit the same or add an existing entry to the admin comment. I know this is a little bit silly example, but this is just to demonstrate where you have a foreign key which is unique and it can be null. Now here we're actually going to see that this relationship on the admin comment itself has a belongs to. So again, if you think about it, note can have an admin comment associated to it. So the comment belongs to note. Now if we go to the notes table and look at the admin comment itself, we now see this new might have relationship. And this is because, as I said, we have a note ID on the admin comment table, which is unique and it can be null. So this is where the optional one-to-one relationship comes into play. So the note might or might not have an admin comment internally, but there can only always be one entry in admin comment. And I hope this all makes sense. We will look at some examples shortly. Now the final relationship is called has one. Now currently there isn't an example in our schema where we have the has one relationship, but has one is pretty much the same as might have. The only difference is that it creates a one-to-one relationship with the class, meaning it's not an optional relationship. So the foreign key cannot be null. So when you create an entry, you must set the foreign key and it must point to a foreign table. In this case, if we had the same relationship on the admin comment on the note, but we didn't have this unique constraint as having a default value of null, then this would be has one relationship. As the definition says, it creates one-to-one relationship with the class, which is not optional. And again, I hope all of this makes sense. Alright, so that's about the relationships and how they work behind the scenes. Now let's see how we can actually query the relational data. In our example, we can say that we want to find all the nodes that belong to a specific user. And if you look at the database and see what we currently have under nodes, we have 3 nodes which currently belong only to user 1. This is going to do for our scenario. So let's say we want to get all the nodes for this particular user. Now how we can do that? We can say that my, and we're going to get back node results. So we can say a list of nodes equals schema result set. So we want to access user, right? So we want to query the relational data. So we first access the user, then we say search result set. Now here we can provide that we only want to search for nodes that belong to the user 1. So we can say ID equals 1. And now how to specify that we would like to join or nodes that we would like to store in our nodes list is we use a keyword called join. And here we provide an array ref and we say that we would like to join a relationship on our user. And if we check the result class, which is called nodes. So if we do that and in our join we say that we want to join the nodes. And now if we say that we want to fetch all the user items firstly, and let's see what happens behind the scenes. So if we say Perl, let's maybe also add DBIx trace equals 1 Perl, and we include our libraries and then run the script. And here we're actually getting an error. And this is good that we got this error, because if we read the message, we're going to see that the error states the column ID is ambiguous in this case. And the reason for that is if we check our nodes table, we have ID column. And if we check our user table, we also have ID column. And we specify that we want to fetch items where the ID equals 1. Now in this case, DBIx doesn't really know to what we're referring. Are we referring to the user table or we are referring to nodes table? Now we have to go back to the fact that whenever DBIx runs a query, as you can see, it always aliases the primary table with me keyword. So here, instead of just using the ID, we can say we want to fetch all the items where the user ID equals 1. If we save that, rerun the script, we're now seeing that the query is run behind the scenes. We're selecting all the fields from the primary user and we're left joining the nodes. Now, of course, here, these are actually not nodes if we think about it. These are users. So we're still selecting everything from the user table and we're just adding the join condition for us to be able to fetch nodes on these user entries. And in our case, we know that we only have one user. So what we can actually do here, we can change this and extract the first item from all the user lists and call this user result. And just to make sure that this actually is a user result, we can do say and user. If we run this, we're going to see that we're getting back a user result. Again, we're fetching all the users, but since we're saying that we only want user 1, then in the list context, there's only always going to be one user result, which is then going to be stored in this first user variable. Now the question becomes how we can access the nodes at this point, because we're getting back the user, we're saying that we want to join the nodes, but we're getting back a user item. What we can do here, we can say now that my list of nodes equals user, and we have a method which is called nodes. And nodes is going to retrieve all the items from the nodes table where the user ID equals 1. And we can do a little bit of debugging here by doing say, do a ref on the current context, which is $_ for all the nodes that we got back. We save this, run the script. We're now going to see that we're getting back 3 results for the node. And again, if we check the database, under the nodes table, we have 3 items. They all belong to the same user ID. And if you look at the script, then this is exactly what we're getting. We're getting back node results. And for more clarity, we can also append the ID as such. So current context and the ID, save this, run the script. We're going to see that this instance is of result node with ID 1, and then there's ID 2 and 3 as well. So one thing just to note here is that previously when we only were selecting our user, we didn't have the second select. And now, since we're accessing nodes, we actually run 2 SQL statements. If we comment out the second part where we're accessing nodes and rerun the script, we're going to see that we're only now selecting and joining the nodes table. So this is one of the key points to keep in mind, is that when you're joining items on the result set, you're not going to automatically subselect all the entries. DBIx is only going to fetch relational items if you actually call a method that indicates you want to access relational items, such as on our user instance, we're calling the nodes to fetch all the related nodes items. And this is why a second query is run. So if we uncomment this and rerun it again, you're going to see that we're fetching the user first, and then afterwards, when we call the notes method, it's running another query to fetch all the note records and construct note results. So that's one important thing to keep in mind. Later on, we're going to see how we can actually prefetch the data. So in case you know you're going to need the relational data, then you might be using a different approach, because using a join and then accessing the relational data later on comes with a penalty, since you need to run additional query against the database. But as I said, we will talk about the subject a little bit later. And another side note is that by default, all the relationships on your result is always going to be left joins. So here, if we check the user result, we don't have a specific relationship here that indicates how we can change it. For example, we also have joins like inner join, but here this is not defined. And default is always going to be a left join. But this is one of those things we're going to look at later on as well. Now, one more final thing is that we are doing a single join here. But what if we actually wanted to fetch more nested relationships? We know that we have user, we know that we have notes, and we know that on the notes we can actually have an admin comment. Now, to extend your joins, what you can do, instead of providing a list of items you want to join directly on the primary table, you can give href user notes relationship, and on that notes relationship we can join additional things. So here, if we check what we do have on the notes, we're going to see that we have admin comment. And again, this is singular because we can only have one item. So if we go back to the script and do this, save it, rerun the query. Now there's just one problem. We don't have any items in admin comment. So we know we have 3 nodes, and let's say we want to add an admin comment for node ID 1. So if you go to the admin comment, we can insert a new record here. And let's just do it through the SQL tab. And what we can do, we can say insert, so insert into admin comment. We provide columns for which we want to insert the data, which in this case is going to be node ID. And the second column we want to provide the data is the comment field. So if we add that, and then we provide the values, which are going to be node ID 1, and we can say this is a admin comment, close it off, run it. Now we check the admin comment table. We're going to see that we have one entry here. Now with this setup, we should be able to access the admin comment on the node if it exists. Now how we can do that is we know that we might or might not have an admin comment. So in this case, we would like to do extra checks. For example, we could say that we want to append admin comment as such. And here on the current context, we can check if we have an admin comment. And if we do, then we want to say current context, admin comment, and then we access the comment attribute. And if we don't have anything, we just want to say there's nothing. Let's align this a little bit better so it's on the same screen. Save this, run the script. Now this is a little bit crowded, but if you look here, that for the first node where we added the admin comment, we're now saying this is admin comment. And for our next 2 nodes, we don't have anything because the ternary check didn't pass. So this part didn't execute, and we just concatenated nothing. So the string nothing. And again, as you can see here, since we're using joins, then every single time when we access the relational data, we're actually making extra queries behind the scenes, which might not be efficient. More on that later on. And perhaps just to make this a little bit clearer, if we rerun the script without debug trace, so let's remove that, just see the comment. We're now going to see that for first item, we're getting the node with ID 1 with admin comment. This is admin comment. And then for the next 2 remaining items, we have nothing. All right, so that was quite a lot. We talked about different join types, and we also looked at how we can join data on one or multiple levels, such as from the user to the nodes and all the way down to the admin comment. I hope you found this video useful, and I'll see you at the next one.